time! Lesson time. Yeah. Okay, so this is lesson 9, and this, my little friends, is where things start to step up a bit. So if you thought I was kind of belaboring things before, it was to prepare you for this moment, because this is where we start comparing decimals. And I will give you one further little warning. Today's comparison lesson is a tad bit easier than what we'll be looking at later when we're comparing decimals in tenths and decimals in hundredths and proper, improper, mixed number fractions all together, like ordering 5 or even 6 terms from least to greatest sort of thing. That's where we're headed. So I'm really trying to make sure you understand this perfectly, so when we get to the more difficult stuff, it's not so difficult. So that's what we're doing today. We're going to use the place value chart, and metric measurement. We're going to compare decimals and answer some comparison questions. Let's do that. All right, so first we're going to start off kind of warming up, getting our heads back in math mode here. Say this number in unit form. Well, there is 1, and we're in the ones place, so it's 1, 1. Now, how many tenths is that? Again, refer back to money. $1 would be how many dimes? 10 dimes, so it's 10 tenths. We got that? Good. All right. Now say this number in unit form. It's 1, 1, and, we still say that and, 2 tenths. Now, 1, 1, and 2 tenths, how many tenths is that all together? Well, we're doing the same thing here, right? We're going to take this 1, 1 and zip it on over here as 10 tenths. So it's a grand total of 12 tenths. We see that. Great. Now, what do we have? 1 tenth. That's the unit form. How many hundredths is that? Well, stop and think. You're probably, not probably, perhaps you're tempted to say, oh, 100 right off. And that would be a perfectly normal human reaction. But stop and think about this. This is 1 dime. How many pennies is 1 dime? How many cents? It is 10 cents. Ah, so we see 10 tenths makes, yes, okay. So 10 tenths makes 1, and 10 hundredths makes a tenth. Okay, so we see the decimal point you can almost think of as a mirror, a double mirror set up that reflects back. So the further you go up the place value chart into millions and billions, the numbers get larger, and the further you go down, the values decrease, the numbers get smaller. Okay, so let's move on. So what's this? Unit form. It's 1 tenth and 2 hundredths. 1 tenth, 2 hundredths. Now what would that be all in hundredths? Well, again, we're taking that dime and changing it out for pennies, same as we just did. So that 1 tenth is 10 tenths over here with the, that 1 tenth is 10 hundredths over here with the 2 already there. Grand total of 12 hundredths. Great. Now, unit form. We have 2 ones and 3 tenths. Okay? What is that all in tenths? Well, these 2 ones are 10 tenths each, so that's 20 plus the 3 already there, 23 tenths. All right, now, same idea, but or similar idea, but we're going to do it now with digits instead of place value discs. Let's say this number, 2 and 3 tenths. See how we read that as a math number? 2.3 is how we'd write it, and we use that way of speaking when I say, how would you write this? But to read it as a math number, 2 and, for the decimal, 3 tenths. Okay, now let's put that into a mixed number, and that's why I was stressing that. 2 and 3 tenths. See, you read it the same way, and as a decimal, 2 and 3 tenths. Excellent. A little faster now. 4 and 6 hundredths. Notice there are no tenths, so we just read what we have there. So 4 and 6 hundredths, 4 and 6 in the hundredths place. Beautiful. Read this number. 1 and, now let's just read this as a number together. 23 hundredths. 1 and 23 hundredths. Now writing the mixed numbers, much easier, right? 1 and 23 hundredths. As a decimal, 1.23 is how we'd write it. 1 and 23 hundredths. Yes, ah. All right, so how about this one? We have 40 and 7 tenths. Same thing goes here. 40 and 7 tenths. 40 and 7 in the tenths place. All right, how about this one? 68 and 5 hundredths. 68 and 5 hundredths. 68 and 5 hundredths. All right, we see how that works. All this little basic stuff here, if you're like, okay, you'll see, you'll need it later on. So now let's write this decimal as a mixed number. So if you read it as a decimal correctly, writing the mixed number is already done for you. That's beautiful. 3 and 1 in the tenth place. 3 and 1 tenth. 3 and 1 tenth. What would that be as an improper fraction? Well, this is what we did last time. So if you're a little confuddled here, you want to go back to lesson 8 and learn this. But I'll give you one explanation here. This 3, well, each one of those 3, each one is 10 tenths. Each dollar is 10 times. So we have 3 of them, so we have 30 tenths here. The value of this 3 expressed in tenths is 30 tenths. There's already 1 tenth here, right? So altogether, 31 tenths. Now, what would that be in hundredths? Well, there are a couple ways of thinking about this. One is simply the same way we did equivalent fractions, and you could probably do this in your head, times 10 tenths. Ah, yes, the shortcut way of thinking of it is sliding along that place value thing, or popping on a 0 is how I sometimes put it, but I try to avoid. We're sliding along that place value chart, so it's 310 hundredths, okay? If you got that, everything that follows will be much easier. Let's do just a little more practice, a little faster. 9 and 8 tenths. Mixed number is going to read the same way. 9 and 8 tenths. How many tenths altogether as an improper fraction? Well, you've probably kind of seen this only works because we're doing tenths, right? It only works because we're doing tenths, but you can kind of look at this and say, well, each of these 9s is 10 tenths, so each of the 1s in the 9 is 10 tenths. So 98 tenths. See how that works? I have a little, call it a shortcut. All right. And now in hundredths, well, times 10 tenths would give us 980 hundredths. Yes. All right. Here's another one. 64 and 3 tenths. Yeah, mixed number is going to be the same thing. 64 and 3 tenths. And now, just do what we did before. Even though this is a 2-digit number, it doesn't matter what we just did before with the 9. 643 tenths, right? 643 tenths. 643 tenths. Now, when you go to hundredths, the number is going to look kind of weird. You'll be like, is that right? It's right, because we're multiplying by 10 tenths here. So we think we're moving them out of place. So a 0 takes the lower place here. 6,430 hundredths. Getting the hang of this? Great. Well, now let's put it to use. We got dogs today. We got Kelly dog. We got Mary dog. We got Hey Jung dog. So Kelly's dog weighs 14 kilograms, 24 grams. Mary's dog weighs 14 kilograms, 205 grams. And Hey Jung's dog weighs 4,720 grams. And just to take a moment and look at those, we could see, obviously, these are in kilograms and grams, but they're different in that this one has a value only up to tens, and this one has a value up to the hundreds, and then this one's just in straight grams. So our job here is to order the weight of the dogs in grams from least to greatest. So in grams, so we're going to convert them all to solid grams, which you'll see is more straightforward than you might think. And then to find how much more does the heaviest dog weigh than the lightest dog. Okay, so if we were to draw a tape diagram, and if you want, pause the video and do this. So here's Kelly's dog, Mary's dog, Hey Jung's dog. Kelly's dog is 14 kilograms, 24 grams. Now, what would that be as a number all in grams? Well, remember that the kilo means 1,000. So it's a neat little way of looking at it here is 14 kilograms, 14,000 grams. So it's 14,000 grams and another 24 grams. Now, you want to avoid the mistake of saying 14,240, right? Because that is not 240, it's 24. All right, so it's 14,024 grams. Then with Mary's dog, 14 kilograms, 205 grams. Well, that one's even more straightforward because 14,000 grams, 205 grams. 14,205 grams. And Hei Zheng's dog is nice and easy because it's already all in grams. So now we can put them in order from least to greatest. What's the least? Hei Zheng's dog, right? By almost 10,000 grams. He's a little cute doggy. So he's the lightest. And then what would come next? They're both 14,000 here. This 14,024, 14,205. Yes, so Kelly would come next, and then Mary's. And that's what it looks like when you have three terms that you're comparing. And you can read this like a sentence. This number is less than this number, which is less than this number. Okay, so that's least to greatest. If you were ordering them greatest to least, you just reverse the signs. So how much more is the heaviest dog than the lightest dog? So if we take Mary's dog here and do what? Right, how much more? We're going to subtract to find the difference between them. And go ahead and pause the video and do the subtraction. Okay, so here's what that looks like. So you can compare my answer with yours. 14,205 minus 4,720. Okay, good. You had to regroup with a zero there, which sometimes can be confusing. So our statement would be Mary's dog weighs 9,485 grams more than Hei Zheng's dog. Lovely, great. And now we can actually get to what we're learning today. We are going to compare pairs, so just comparing two numbers. That's a good thing to know, because I said it will get more later on. Decimal numbers representing length. Okay, and we know from our objective that we're doing metric measurement. So what do we use here in Eureka 4th grade? Yes, meters and centimeters and kilometers. Very good. Okay, so what's this? Well, it seems like we have two tape diagrams, right? This one is 59 hundredths. This one represents 67 hundredths. Okay, so just looking at that, if I were to ask you, well, greater than, less than, equal to? Obviously 67 is greater than 59 hundredths. Okay, so we're all good with that? All right. Obviously I'm starting out easy. So does this make sense? Oh yes, if this wasn't just a tape diagram but a meter stick, then 67 hundredths of a meter is more than 59 hundredths of a meter. And you remember that with 100 centimeters in a meter, 67 hundredths of a meter is 67, yes, centimeters. And 59 hundredths meter is 59 centimeters. So, voila, mathemagic! This also is true, yes. All right, we can look at it as well in a place value chart, and in this one it's not quite as necessary, but with some down the line you'll find this even more useful. But we want to compare by starting in the tenths place, because tenths are more than hundredths. 6 is more than 5, you're done right there. You don't even really need to look at the hundredths place, but we can, it doesn't matter. But we can say, oh, 6 is more than 5, this is greater than that. Okay, lovely. Here are two different numbers, and you see already right off you said, oh, there's a difference here. That this one is in tenths, and this is in hundredths. And I hope this chart isn't misleading to you. These have been partitioned here, but they are not shaded in. Only the first four here. So this is 10, 20, 34 hundredths, and this is 10, sorry, I should count this way. 1, 2, 3, 4 tenths, okay, because it's in tenths. So now, if you look, this is where 34 hundredths comes. Which one is more? Okay, the 4 tenths is more. Does this help? Now, see, maybe the place value chart helps. The mistake here would obviously be what? To say, oh, 4 is less than 34. Not when it's 4 tenths, though. All right? So you can see here we go to tenths place like we just did in the last one and say, 4 is greater than 3. Done. This is greater than that. Okay? Does that help you see it now? When we convert it to centimeters, 40 centimeters is more than 34 centimeters. And once again, if we're talking about money, 4 dimes is 40 cents, and 40 cents is more than 34 cents. Cents is hundredths, hundredths is cents in our minds. Now we're going to do the same thing, but with decimal numbers representing mass. What did we do for mass measurement in the metric system? It was, yes, grams and kilograms. So here we go. Ooh, remember the rice? The rice is nice. The rice is back. This is 1/10 kilogram. Here we have a bigger bag. I tried to make it bigger. 65 hundredths kilogram. 7/10 kilogram, and 46 hundredths kilogram. Now if we were to compare these, and I said, well, which one is smallest? Here's the way you might think. You'd go 1, 7, 46, 65, and put them in order like that. Where would my mistake be there? Okay, so now what we're going to do so you can see where that would go wrong is if we put it out in a place value chart, you can see with the 1/10, it's 10 hundredths. And I didn't write the 0 here, but this 7/10 would be 70 hundredths. So now when you go from heaviest to lightest, let's go from heaviest to lightest. Okay, so the heaviest one then is 70 hundredths, which we have written as 7/10. Then what would be next? 65 hundredths. Next lightest, 46 hundredths, and the lightest one, 10 hundredths, or as it was written before, 1/10. What other kind of comparisons can we make here? Yes, you. Yes, yes. We can say that's very good, that this rice bag C is 7 times heavier than rice bag A. What else could we do? Yes, yes, you. Very good. Good point. We can say how much heavier is each bag than any other one. We can do comparisons that way, that 70 hundredths is 5 hundredths more than 65 hundredths. Which bags are closest in weight? Okay, so picturing that 0 here, you can see that 70 and 65 are only 5 away, that those are closest. And obviously what's your furthest would be, right, the heaviest and the lightest, the 7/10 compared to the 1/10. Beauteous. That's something we had in the objective back there, was, doing some question answering about this. One more thing, volume. Volume is capacity, how much space something takes up, whether you're talking about, usually used for liquid, but also for gas measurement. No, not like that. Oh my goodness, 4th graders. All right, here we go. 3/10 liter, 15 hundredths liter, 29 hundredths liter, 9 hundredths liter. Well, we lay this out in a nice little place value chart like we just did, and we can compare them. Okay, now all we'd have to do here is say, well, we can call this 3/10 30 hundredths. You see why we did a lot of warm-up with this. And then if we were going from most to least, which one would be most? The 30 hundredths, wouldn't it? And then what's very close to it? 29 hundredths, then 15 hundredths, and lastly, 9 hundredths. What would be the mistake someone might make? Right, to see the 3 just as 3, and then put them in order, most to least, 29, 15, 9, 3. But this 3 is actually not the smallest one. It happens to be the largest one because it's 3/10, which is 30 hundredths. So which volumes are closest? I bet you already caught that, right? That the 30 hundredths is only 1 hundredth away from 29 hundredths. And what's your furthest? Again, it's going to be the largest versus the smallest. And how far are those? Can you figure that out in your head? 30 hundredths from taking 9 hundredths from that? Yeah, a difference of 21 hundredths. Very good. All right, look at that. Here we are onto the problem set. Doesn't this look like the first ones we did where we were comparing decimals? using the tape diagram meters. These are tenths of a meter. So this is 1, 2, 3 tenths. This is 2 tenths, and oh my goodness, I think that's 7 hundredths. So this is 3 tenths and 27 hundredths. And if you even just look here, you see here's where they line up. You can see that the top one is more, okay? And note that you're supposed to write a sentence here saying, you know, this one is shorter than, or this one is longer than that one, sort of thing. Another example of that sort, and then for both A and B is how you compose C. Just give us a list, all 4 lengths, comparing all 4 of them from least to greatest. That's preparing you for more comparison questions later on. This is similar to what we did with mass, with weight, right? Because here is linear measurement, length, and here is mass / weight. There is a scientific difference there, but not for our purposes today. And you are just going to put them, put an X on everything that's heavier than the avocado, okay? And there's no toast there. All right. And then taking those 4 values, which I put at the top of the page here so you could see what I was doing. I took those 4 values and put them up here. You want to put them on the place value chart. Okay, make sure you put everything in the right place. Decimal point is your guide. And then you're going to use the statements heavier than, lighter than to compare some of them. All right. And then same thing again with volume, also known as capacity. You have now, you see it's getting a little thicker, right? They're giving you 6. Fortunately, they're all in decimal form. That will get more complicated down the line, but 6 of them to compare. And then it picks out 3 of them here just randomly to say greater than, less than, equal to. And you will write them all then, all 6 of them for D there, in order from least to greatest. Exit ticket, same thing but simpler. Again, greatest to least. A couple of just straightforward comparisons here with mass. And they actually leave off the capacity there. We just have the linear and the mass measurement. Okay, then when you get to homework, you know what to do. It is the same kind of questions here, the same 6 cylinders, but with different values. But you hop over to homework time and do it with me there. Well, look at what you have gone and done. You have completed yet another Eureka math lessons. Bully for you! Which is an expression meaning good for you. So I will have to see you then again next time. That's right, next time it is once again a lesson time.